Good morning, all. Hello, guys. Good morning, all. Hope you all are doing good. Right now, today we'll see the problem. Find the smallest balanced index from weekly contest 492. Okay. So, in the question, let's read the question once. Let's read the question once. You are given an integer array num I is balanced if the sum of elements strictly to the left of I equals to the product of elements strictly to the right of I. So, uh, so basically, we are given an 1 minute. Okay, so basically, we are given an array. Correct. We are given an array. Let this is the ith index. So, a index is balanced as per the question. Index is balanced if the prefix sum up to I minus 1 index and the suffix product from I plus 1 index is equal. So prefix prefix sum up to I minus 1 index is equals to suffix product from I plus 1 index. Correct? Yes. Then the ith index will be balanced. Balanced. So how we can do this one? How we can do this one? We'll calculate a prefix sum array and suffix product array. Correct? Product array. And we'll calculate the prefix sum and the suffix product from the 0 to n minus 1 index. Clear? And for suffix product we'll calculate from n minus 1 index to 0. Okay, so we'll calculate and we will see at the ith index if prefix sum of I minus 1 is equals to suffix product of I plus 1 hackney. If it is, then we'll return the index. Return the index I. Correct. But if you see the constraints, right? Now real problems come with constraint. Okay. So here they give the constants like this. This E, 1E and 1E5. Okay. So let's now let's say that there is total 1e5 number of elements. Okay, and each of the elements is like 1e9. When you are calculating the suffix product, right? Suffix product, then it will be like 1e9 multiplied by 1e9 multiplied by 1e9, like up to, let's say, 1e5 minus 1 for the like first element, right? No, sorry, zeroth element. For zeroth element, if you want to calculate, there will be like 1e5 minus 1 elements, and at up to that time you need to multiply that one, and it will be like huge number. You cannot able to store that number, correct? So how can you do? How can you solve this? It will give like out of memory, right? Out of memory exception for prefix sum. Sorry, suffix product. Suffix product के लिए that will give out of memory. So how to resolve this? Now, if you see clearly the question, okay, they are asking right now. I'll tell that crux of this question. Okay, now they are asking key if suffix product of I plus one can be will be equal to prefix sum or not. Okay, prefix sum of I minus one or not. Okay, now if you see what can be the maximum prefix sum, so we have, let's say, 1e5 elements and each of element is 1e9, correct? So 1e9 plus 1e9 plus 1e9 plus dot 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 up to 1e5 times. Okay, so the maximum prefix sum can be 1e9 multiplied by 1e5, right? That is equals to 1e14. That is our what you say, main thing. That is our main thing. We need to check. So what, when you are calculating, when you are calculating sorry suffix product, if if my product my product is greater than if my product is greater than 1e14, then definitely this could not be the answer, right? This could not be the answer, because we need to check the prefix sum equal to suffix product or not, correct? If my suffix product is greater than 1e14, then this cannot be the my answer, because at most if you see my sum is belongs to one e 14 taki, like it can be there. Okay, that prefix sum. So there is no meaning to calculate the suffix product beyond 1e14, right? No. So we'll check while calculating suffix product. If my product is greater than 1e14, then I'll put a limit, let's say 1e14 plus 1. This is my max limit, right? Max limit. So I'll put that in this product part, like let's say suffix product of I is equals to the is like it's greater than that limit, right? Greater than limit, then I'll put that product as is limit. Then we'll check after doing all the operation, then we'll check, we'll matching if prefix sum is equal to that suffix product or not, because limit is like 1e14 plus 1, that can be hold. It's not out of memory if you can store it in long, right? So we'll use this logic to solve this question. So question is very simple, but the constraints provided in the question is make it hard, because you can't able to multiply to one. It's like huge 1e 9 whole raised to 1 is 5. So let's code this. This is the class. If suffix product of I is greater than the limit, then we'll put just limit. And one more thing, if you see the constant is started from 1 to 199, right? So let's say suffix product of I plus 1, if it is equal to limit max limit, that is 1 is 14 plus 1. Okay, then obviously suffix product nums of I multiplied by suffix product of I plus 1, right? So this is at the extreme limit, like 1e4 plus 1. Obviously this value also will be in the extreme limit, exceeding the extreme limit. If you multiply it, as nums of I can be 1 to 1e9, right? So obviously it will be either limit or it's above the limit, right? So in this case, if I find that suffix product of I plus 1 is equal to limit, then obviously my the entire left side will be also limit. Suffix product of I, then I minus 1, I minus 2, everything will be limit. Okay, because it's not, it will be always exceeding that limit number. If you multiply it, even if you multiplied with 1, then the same number will come. That, and 1 is the least value, right? 1 is the least value in the nums can have. Okay, so with that logic, let's code this question. So first of all, we need to check, uh, we need to make an array. Let's say, okay, let's create a long type, long limit. Okay, equal to long type 1 is 14 plus 1. Okay, now I'll make an array of long array is equal to new long. Let's take the int n equal to length. Let's take the length. Sorry, n equal to nums dot length, and I put n plus 2. Why I'll put n plus 2? I'll tell you. So basically, so in this question they are saying ki if some sum is not there, like for example for 2, this 2, the prefix sum will be 0, and for this 2 the suffix product will be always 1. So I will put 2 more extra memory for that one. Okay, so I will assign that one array of 0 is always will be 0, and array of n minus, sorry, that will be n plus 1 is always will be 1, correct? Now let's fill the array for int I is equals to 1, I is less than, I is less than or equal to n, I plus plus. So what will be array of I is equals to your sums of I minus 1, correct? Now I will make two long, okay, suffix product equals to new log. There also I'll put n plus 2, fine, and then prefix sum equal to log n plus 2, right? Now, correct? Now, now we know that prefix sum of 0 is always equal to 0. Fine. Suffix product of n plus 1, right? It will be always 1. Correct? Or I can use the array for suffix product. I can use the array. Prefix sum is also not required actually. Sorry. So right now, I will build the suffix product. Okay, in the array itself, I will build int for int and I equals to n, because n plus up to n plus 1 there will be element. I equal to n, I is greater than 0. Greater than 0, why greater than 0? Because at the 0th position it will be 0 for prefix sum, right? I minus minus, then I'll check if if array of n plus 1, right? Sorry, not n, I plus 1. I plus 1 is equal to, sorry, equals to limit. If already limit, I told you ki if it is already reached the limit, then the current value is also will be at the limit, right? Else else I will calculate the value. Value is equals to your array of I multiplied by, sorry, not array of I, is okay, this array of I multiplied by array of I plus 1. Okay, now if my value is exceeding the limit, right? Exceeding or equals to limit, correct? Exceeding or equals to limit, then obviously array of I is equals to limit, right? Else if it is not, then array of I multiplied equals to array of I plus 1, right? So I am using my array to calculate what? Calculate that, what you say, suffix product, correct? Now I will put long prefix sum as equals to 0, and we'll try to iterate from int I equal to 0, from I is less than n, I plus plus. Okay, now if I'll check ki if my prefix sum is equals to what do you say, array of I plus 2. Why I plus 2? Because array of 1 will contain array of, sorry, nums of zeros value, right? Array of 1 contain nums of zeros, and we need to, I need to check the strictly right side and strictly left side of the element, right? So I'll check for this one, array of I plus 2. I plus 2, array of I plus 1 will contain the value for the ith number, right? So I plus 2 will contain the product of from I plus 1 to nth, correct? So if, then I'll return I, else I'll add the prefix sum plus is equal to your nums of I, right? because we are checking for nums of I, right? If it is not seen, then it's not possible actually. Fine. Let's run this, and if you see, we are getting the correct results. Correct, and we'll submit that one. Yeah, you can see this correct solution, right? Uh, we'll see in the next video. Thanks. Thanks a lot.